Those are the boys.
Are we good?
Looks like it.
Okay.
Yeah, I think all this time. It's kind of crazy.
Okay. Who here is ready? All right. So my last class ended a little bit early. And so I had to figure out, I don't want to sit here at the end of the class for 10 minutes with nothing to do. So I had to figure out something cool to teach you guys. So that's why I was late. I had only a short amount of time to figure out something cool. Okay, so that's why I was late. And if we get to the end of the class, then you'll see something that is hopefully cool. All right, now for the fall 2006 final, I had this question up before reading week. I put this question up. I didn't solve it for anyone. Those of you that were at my office hours saw the solution to this. So I'm not going to spend too much time on it because some people are going to think it's a waste of time because they've already seen it during the office hours. But this is a question from the 2006 final. All right. There's this polynomial. It has integer coefficients. M over n is a rational root in lowest terms. What does it mean to be a root? Grayson? Yeah, so m over n is a root. That means f of m over n is what? Perfect. And it's in lowest terms. Is 12 over 6 in lowest terms? Okay, is 19 over 4 in lowest terms? Okay, how about 16 over 6? Okay, so everyone knows lowest terms since grade 9, right? Anyone that doesn't know lowest terms? Speak now or forever hold your peace. Everyone knows lowest terms. Okay, good. So now prove that m divides e. Easy? Okay, I'm going to go through this fast because some people have already seen this proof because they came to my office hours. And it's a pretty easy proof anyway. So we're going to just plug in m over n is a root. So f of m over n equals 0, right? Okay, easy. What are we going to do next? Grayson? We could do that. Yeah, we can do that. I'm going to do that 2 steps from now. You can do that now or you can do that later. It doesn't matter the order. Versano? You can multiply, if you multiply by n, what's m over n to the 4 times n? Okay, so what can you do? It's a good idea. He doesn't like denominators, neither do I. How are we going to get rid of the denominators? Hey, you guys know the answer already. How do you get rid of the denominator here? Come on, this is easy, isn't it? Versano.
You multiply by n to the 4.
Yes, multiply by n to the 4. Okay, we get this. Multiply both sides by n to the 4. Good. Now we do Grayson's idea. Subtract e from both sides. Actually, forget it. We're going to do that in the next. So here we factor out the m because we want to prove that m divides e, right? So let's put e on the other side and factor out the m. So we factor out the m. Boom. Here, we're done. And then we put the e on the other side. Okay? Everyone's good? Okay, now we want to prove that m divides e. How are we going to do that? Paige.
We know that m doesn't divide n because the rationals in lowest terms.
Yes.
So it has to divide e.
Why does it have to divide e?
That's the only other thing that's multiplied by.
Okay, how many people agree? Marissa agrees. You have some loyal friends here. Anyone else? Maybe you agree, but you think it's not a good enough proof. Some people are now nodding their heads. Rest of the class is silent. Okay, so first of all, does anyone disagree that m divides negative en to the 4? Anyone disagree? No, because here I have negative en to the 4 equals m times a constant, and this constant is an integer. So everyone agrees with this, m divides negative en to the 4. That means m divides en to the 4. All right, so why do you guys disagree why do you disagree with Paige? M does not divide n to the 4, right? M does not divide n to the 4. Does everyone agree with that? Does everyone know why M does not divide n to the 4? In the last class, someone didn't quite get it. Versano, you don't get it? M over n is in lowest terms. So they don't share any factors. Is 12 over 4 in lowest terms? Why? Because you can divide both numerator and denominator can be divided by 4. So if m over n is in lowest terms, you've already taken out all the factors. So m does not, m and n to the 4 do not share any common factors. M and n don't share any common factors. That means m and n to the 4 don't share any common factors. Okay, but now m divides en to the 4 and m does not divide n to the 4. Does that mean that m divides e? By you nodding your head, you're confusing some people. Even Grayson's nodding his head. That's a mistake, isn't it? Well, so Grayson, m divides en to the 4, m doesn't divide n to the 4. Does that mean that m divides e?
Not necessarily.
Based on what? Why are you saying m divides en to the 4, m does not divide n to the 4? What are you using? DIC, transitivity? What are you using? Why does it, why do we know that m divides e if m divides en to the 4 and m does not divide n to the 4? Transitivity. So that means if m divides en to the 4 and m divides.
I mean, I guess it's like the converse of transitivity.
Okay, so you think you can prove it using the converse? Yeah, how many people think that they can prove this? M divides en to the 4 and m doesn't divide n to the 4, then m divides e. How many people think that they can prove that if they were given 10 minutes at home? Okay, well, it looks like it looks pretty obvious, right? Like m divides this factor of two things. It doesn't divide one of the factors, so it has to divide the other factor, right? Seems like common sense. But if you try to prove it using the converse or doing some other technique, it might not work so well for you. Okay, so m divides e because m divides this and m doesn't divide that. But is the last step okay? And when you Google this, I say, okay, let me Google this. This isn't a theorem in the course notes yet. So A divides BC, then does A divide C? If A divides this product, then does it necessarily divide this C? Then first thing I find on Google is if the GCD of A and B equals 1 and A divides BC, then A divides C. That is a theorem. It's called Euclid's lemma. All right, so it is true. But when I look at the proof of Euclid's lemma, all right, so here's the theorem. If n divides AB and n is relatively prime to A, that means that n and A don't have any common factors, then n divides B, okay? So this theorem that Paige is using, that is a correct theorem, okay? It is correct, but how do you prove it? You go further down, you get the proof. Using Bézout's identity, you prove this. Have we taught you Bézout's identity? So if you use this if you said on the midterm, this is trivial, how do you prove it? We haven't taught you Bézout's identity, right? You can also prove it directly, but to prove it directly, you need to use strong induction. And these are the only two, I didn't have space to put the whole Wikipedia page here, but these are the only two proofs given. And if you look in the course notes, chapter 6.7, we cover Euclid's lemma there, and we don't give you any more proofs. Basically, you can prove it with Bézout's identity or with strong induction. Other methods, you can try it. You can try to prove the converse or something. First of all, just because the converse is true doesn't mean that the forward implication is true. You can try the contrapositive. You can try various things, but these are the two proofs that I was able to find. And they're not trivial, right? We didn't teach you Bézout's identity and we didn't teach you, well, we taught you strong induction, but it's going to take a long time. You have to prove it for n equals 1 and then n equals k, assume that it's true for n equals k, and then show that the fact that it's true for n equals k implies that it's true for n equals k plus 1. That's quite a lot of work. So even though this looks so trivial, if n divides AB and n and A don't share any common factors, then n divides B. It looks so trivial, but it's not, okay? Lesson number 1. Things that look trivial are not necessarily trivial. You actually have to prove it, okay? Once you start trying to prove it, you realize, wait a minute, is this theorem even true? Okay, that's part of this course. So who's ready to learn Bézout's identity? No one is ready to learn Bezout's identity. Okay. Well, Bezout's identity is powerful because with Bezout's identity, you can prove this in one line. Well, a few lines, I guess, but it's powerful. It's able to prove the thing that no other technique was able to prove for us other than strong induction. So if you want to learn Bezout's identity, you better start reading. Okay, how is it that we learn theorems in this course? We read. So first ASAP, I would say start working on assignment number 5. Who here is done assignment number 5? No one. Who here has started? Who here hasn't started? Uh-oh, a lot of people haven't started. Okay. How many people are half complete? Good. All right. So assignment number 5, I think you should start working on that because it's due in a week. And complete reading 6.1 to 6.3. This includes Bezout's identity. This is only 8 pages, so don't worry. It's really not that much reading. It's really not that much reading. You also have to read 0.4 of the polynomial section, but that's about chapter 6.1 is the division algorithm for integers, and 0.4 is the division algorithm for polynomials, so they're very similar. Okay, so I think you should start reading this stuff as soon as possible. Don't forget there's a Mobius quiz due today. Some of you forgot about Mobius quizzes, right? Because it's been so long. Okay, then Friday's class, I'm gonna start in the class. I'm just gonna be doing problems where I assume that you have read pages 93 to 101. So I hope you can read that by Friday. That way I can start doing problems. I'll just say GCD of this and this and GCD of that, and you should immediately know how to do it because you've read all the things. It will be very obvious who hasn't read those pages. Then you have a couple more Mobius quizzes, and then there's the assignment due on Wednesday the 27th. You might as well finish this Mobius quiz before that assignment, because that Mobius quiz might have some questions on it that might prepare you for the assignment. They're both covering material from 1 to 6.3. The other thing is that if you do this assignment, you submit it at 5 p.m., then you do the Mobius quiz from like 5:30 to 6:30, then it's 7 o'clock, then you have no time to do the reading. And I think that it would be very useful for you to do the reading by the Friday, because on the next Friday, I'm going to be covering 6.4 to 6.6 in the lecture. All right? So that's it for the schedule. Those of you that have started assignment 5, which question was the hardest for you? Who started assignment 5? One person, 2 people. Only 2 people have started assignment 5? Yeah, which question was hardest? Which?
I haven't gone to the GCD part, so.
Yeah, so questions 4 and 5 are about GCDs. You can ignore that. I don't really expect you to start questions 4 and 5 right away, but that's why I'm asking you to read sections 6.1 to 6.3 as soon as you can. Usually I would have assigned it long ago, but because you had the midterm, I didn't want to assign any readings. I'm like, okay, they're stressed. They have to focus on this midterm. Let me allow them to focus on the midterm for now and then catch up on the readings later. But you should read 6.1 to 6.3. It's only 8 pages, but you need to know that to do questions 4 and 5 of the assignment. So out of the questions that you did try, questions 1, 2, and 3, maybe, which one was the hardest? 2, 3? Yeah? Has anyone done 1C? A lot of people haven't tried 1C yet, so, oh, you guys have done it, okay. A lot of people haven't tried. Unfortunately for you, you haven't tried it. I'm gonna be giving tips today. You might not even understand what I'm talking about because you haven't even tried it yet. But this is the last I'm gonna talk about 1C. I'm gonna give you a hint for 1C, but I'm gonna go quickly because some people have already tried it and already finished it. No one said that 1C was the hardest question for them. So I'm just gonna go through this one quickly. All right, so suppose that for some integer n greater than or equal to 3, when 2 plus 3x to the n is expanded, the coefficient of x cubed is 3 times the coefficient of x squared. Determine the value of n. Is this visible from the back? Jimmy, Henry? Yeah, okay, good. So what's the coefficient of x cubed in 2 plus 3x to the power n? Is your hand up, Johan? No? Alina? What's the coefficient of x cubed in 2 plus 3x to the power n? 3 times a, okay, yeah. But you already finished this question, right?
Like, I'm done with the.
Yeah. Yeah, okay. So someone else? Paige.
It's like, I've been using like the binomial theorem, like, or the choose function. So
Very good.
it's like n choose, if we want the x to the 3, it'd be like n minus 3, or it'd be 3.
And she's.
Yeah, n choose 3 times 2 times 3.
Times 2 times 3? How many people agree with that? Okay, you guys don't know how to get the coefficient of x cubed in 2 plus 3x to the power n?
We used to use the binomial theorem, right?
Yeah, you use the binomial theorem.
And choose r x power n minus r times into y times r. So here x is 2 and you can take 3x as the y term. So your coefficient would be n choose 3.
And choose 3?
2 times 3 minus r and times 3 times x to the power 3 because you set r to 3. So essentially I have n choose 3, I think 2 times r divided by 2 times divided by 8, basically 2 to the power 3 into 3 times 3. So that's your coefficient.
All right, well, that's a lot of words for saying n choose 3 times 2 to the n minus 3 times 3 cubed. Okay, so this is binomial theorem, all right? If you don't know how to get this, this is midterm material. We could have put this on the midterm. This is just chapter 5, right? It's just midterm, it's just, this was already covered. You already studied for this. Binomial theorem states that if you have 2 plus 3x to the power n, you can use the binomial theorem to figure out these n choose 3, those are related to the coefficients of this binomial expansion. So we have n choose 3 times 2 to the n minus 3 times 3 cubed. They also talk about the coefficient of x squared in the same function. So what's the coefficient of x squared? Someone else now. Hey, come on, you already know it. Everyone forgot the binomial theorem? Hey, you guys already finished the question. Let's get someone else. Yes.
It would be n choose 2 divide by 1 to 3x.
3 what squared?
So 3x.
3x squared? Why is there no 3x cubed over here?
Without the x. Because it's equal.
Without the x, okay. So n choose 2 times 2 to the n minus 2 times 3 squared. All right? Okay, what's the coefficient of x squared in this? N choose 2, 2 to the n minus 2, 3 squared. Good. Now, here in the question, it says that the coefficient of x cubed is 3 times the coefficient of x squared. All right, so let's let the coefficient of x cubed be capital A and the coefficient of x squared be capital B. Okay, got it? All right, so we're going to have to, we know that the coefficient of x cubed divided by the coefficient of x squared, that means capital A divided by capital B, that is going to equal 3. Right? Because the coefficient of this thing divided by the coefficient of that thing is 3. And then we have to determine n. So what happens if we divide A over B, we get 3. But what happens if we divide this thing over that thing? Okay, we all know how to divide 2 to the n minus 3 over 2 to the n minus 2 and 3 cubed. What's 3 cubed over 3 squared? Easy, right? You all know. Yell it out. Good. So you already know how to do this divided by this. But n choose 3 divided by n choose 2. Can anyone say quickly what that is? N choose 3 divided by n choose 2? Versano?
Use Pascal's idea.
I mean, you use something, but what is it? What is n choose 3 divided by n choose 2? Grayson?
N minus 2 factorial times 2 factorial over n minus 3 factorial times 3 factorial.
Yeah. So you write n choose 3 in terms of the factorials, and you write n choose 2 in terms of the factorials, and you divide them. In the end, I'm going to save you some time here. Okay, this thing n choose 3 divided by n choose 2, it's equal to n minus 2 over 3. Prove that at home. Okay, prove it at home. I'm just saving you some time. I'm just giving you that step. You don't have to spend. You already know what it is. Now just prove it. So this part divided by this part, I've given that to you. Now, 2 to the n minus 3 divided by 2 to the n minus 2, what's that equal to? Quickly, yell it out. Say it loud.
Yeah, 1/2.
1/2. Okay, good. 2 to the n divided by 2 to the n. The 2 to the n's are gone. Then you have 2 to the -3 over 2 to the -2. So you have one extra negative in the exponent. That means you have 1/2. All right. So that is equal to 1/2. So we have that this divided by this equals n minus 2/3. We have this divided by this is half. This divided by this is 3. So now we know the right side of this ratio, it's going to be this divided by that. It's going to be some function of n times a half times a bunch of other stuff. It's just going to be some function of n. And that equals a over b. And what's a over b? Say it louder. 3. Why is that? Because the question says that the coefficient of x cubed, that's capital A, is 3 times the coefficient of x squared. It says that in the question. So now we have that a over b is 3. And then we have that this thing over this thing is just some function of n minus 2/3 times 1/2 times a bunch of other stuff. And then you just solve for n. The question says determine the value for n. All right, so you can all do that at home. Everyone's going to get 100% on this question. Very good, very good. Okay, question 2. This is the one you said was the hardest, right?
This question. Yeah.
Who's done question 2? One person's done. Anyone else? Oh, good. Cindy's done, Marissa's done, Alina's done. Oh, very good. Oh, I should go through this lesson even faster. Okay, how many people struggled with question 2? Okay, the same people that put up their hands, they struggled a little bit with question 2. Okay, so let A be an integer and let S be an odd prime. Let T be the set of integers such that X does not divide 3A cubed minus A. Let W be the set of integers such that X does not divide 7A cubed plus 3A. Show that P, being an odd integer that doesn't divide A, is a subset of T union W. Quite a lot of words there, right? What are we going to do? If a question like this comes up on the midterm, what are you going to do? Viha. Convert it into, well, why would you take the contrapositive? Why would you do the contrapositive?
I'm assuming right now that since everything is not divided.
Okay, because you don't like the does not divide symbol. Good idea. Okay, okay. So first thing, we have all these sets and we have all these words. Let's make sense of that. Let's turn it into symbols. Let's turn it into symbols we understand from chapter 1. Okay, what exactly do we want to show here? So if this set is a subset of this set, what that means is that some element of this set, so if P is in this set, then P is also in this set, right? We're trying to say that this set is a subset of that. So any element in here is also in there, right? Just as simple as that. If P is an element of this set, then P is an element of that set. That is an implication. Okay? You're going to do the contrapositive. You're gonna say P is not in that set, then it already is an implication. A implies B. So you're gonna do the contrapositive of this?
No, like write it down.
Okay, so let's take the T union W. Let's make sense of it. It's a set. It's in this weird notation. Let's turn it into notation we're familiar with from chapters 1 and 2. The first thing we have here, P is in the set S. S is the set of odd primes. So P is an odd prime. And P does not divide A. It's an odd prime that does not divide A. Got it? Now what's T? T is the set of integers such that 3A, X does not divide 3A cubed minus A. So we say that an element in T does not divide 3A cubed minus A. And its union, if I have a union, T union W, that means that it could be in T or it could be in W. So W is saying that the element does not divide 7A cubed plus 3A. Okay, so we have that. All right, so we have something of the form A and B implies C or D. Okay, that's what we have. A and B implies C or D. Now, why do we take the contrapositive?
For this one,
Because we don't like the do not divide symbol, right? All right, so let's get rid of all these does not divide symbols. There's 3 of them. If there's one does not divide symbol and there's one does divide symbol, then maybe you don't do contrapositive because then you're removing one but adding another. But here we have three divide symbols and they're all does not divide. So let's just do the just convert these all to divide. Then we can use DIC and transitivity and all those other things because we know theorems about things that divide each other. So contrapositive, not C or D implies not A and D and B. And then we use De Morgan's laws. Okay, quick. Not C and not D implies not A or not B. De Morgan's laws, easy. Now we convert these into we convert this into a language we understand. Instead of C's and D's and A's and B's, we actually make it more concrete. What does it mean to be not C? If P doesn't divide 3A cubed minus A, the negation of that is that 3 does divide it. Same here, P does divide this. P is not an odd prime. Here, P is an odd prime. P is not an odd prime here. And here we have P doesn't divide A, that becomes P divides A. Got it? Okay, so from here, you know what to do? I just made this so easy for you, didn't I? This is so easy now, right? You just have P divides something and P divides something else. What are we gonna do next? You already know, yell it out. DIC, P divides this and P divides that, then P divides some integer combination of this and that. I don't even remember the answer to this question, but I can already assume that we're gonna wanna get rid of one of these A's or something, right? I have A cubed and I have A cubed. I don't have any A cubes on this side, so I can probably come up with some integer coefficients such that the A cubes are gone. Maybe I'll have just A, and then I have that P divides A. And if P doesn't divide A, then we have to prove that it's not an odd prime. Okay, so that's pretty easy now, right? Question 2 is easy now, right? You struggled, but now you have some confirmation that you did it right. Okay, question 3. Prove that this set equals that set. How many people are done? 3 people are done. Hey, other people should start working a little bit harder because these classes are going to be boring for some of these students that are working harder. So my advice for this, so it says prove that this set equals that set. And then for part B, it says hint. Oh, sorry, it doesn't say hint. For part B, it says the sets in part A are very special. What set is it? So A and this set A and this set B, they're equal to each other. And they're both a very special set. And it says, what is that set? I would recommend that you do 3B before you do 3A. That's my recommendation. First, figure out what this special set is. Once you know what that special set is, then instead of trying to prove that this thing equals this thing, instead, both of these things are equal to some special set. So instead, you can prove that this thing equals the special set, and this thing equals the special set. And because set A equals special set and set B equals special set, then set A equals set B. Got it? Vihang?
So everyone's are called, or like is there special properties?
So the sets in A are very special. I'm not going to tell you what that special set is, but there is some special set that corresponds to both this one and that one. Okay, so you figure that out first, and then you'll be able to do 3A much easier. And then instead of proving that this set equals that set, prove we have the special set S. Prove that this first set equals the special set, and the second set equals the special set. That's the same as proving that the first set equals the second set. Got it? All right, so where S is the special set that you discovered in 3B. Now, what does this mean? So if this set equals the special set, I told you I want you to prove that this equals the special set and this equals the special set. What does that mean for this to equal the special set? Versano.
Improper subset.
Okay, so you're basically saying, what, is it enough to show that this is a subset of S? We want to show that it equals S. Does being a subset of a set mean that you're equal to the set?
Sometimes.
Sometimes. So Marissa? Okay, so this set has to be a subset of S, and S has to be a subset of this set. Got it? Very good. So this set is a subset of S, and S is a subset of this. Good. Now, once you know what this set is, proving that 5a plus 7b, where a and b are integers, all of the elements in this set are a subset of this special set. That's going to be super easy once you know what the special set S is. It's pretty easy to show that 5a plus 7b is in that set. What might be hard is showing that that special set is a subset of this set of integers. Okay, that might be a little bit harder. So you guys figured it out. Marissa, you figured it out? Alina figured it out?
I didn't do that method, I just showed that 5a plus 7b is a subset of.
You showed that 5a plus 7b is a subset of the special set.
Oh, no, not the special set, I just,
Oh, you just did it directly. This equals that.
yeah.
Okay, yeah, that might be harder. Yeah, I haven't looked at that proof. I'm going by what the proof that I know. And how about you, Grayson?
I did it the same way. I just showed the equality between the two initial sets.
Okay, so you show that this equals that. Okay, yeah, so I guess it's not that hard to do it that way. But if you do it this way, this is at least what I've seen according to the solution scheme. So we might as well, this is probably going to be the easiest way for a lot of people now that I've given you the hint that you do part 1b first and then you do the rest. So now that you know that you want to prove that this equals the special set, you say this equals, this is a subset of S, that's going to be easy to prove. Then you say that the special set is a subset of this. If you do want to do it this way, I'm going to give you another hint. Let X be an arbitrary element of S. So S is a bunch of elements. Let X be an arbitrary element of that and show that X can be written as 5a plus 7b. Therefore, any element in S is also an element of this set because it can be written as 5a plus 7b where a and b are integers. Got it? Got it? Okay, and I'll give you another hint. Your choice of A will depend on X and your choice of B will depend on X. So it might be something like A equals 4X and B equals negative 3X. Then does 5A plus 7B equal X? No, it doesn't. But maybe if you chose different integers, you might get that 5A plus 7B is X. So if I have 5 times 3x, which is 15x, plus 7 times, I don't know, some other multiple of x, then I might end up with like 15x minus 14x and get x. Oh, did I just solve it for you by saying that that's 7x times 2? Okay, sorry. That was just thinking too fast. I was just trying to give you an example and then I accidentally did it for you. Well, that's not actually the answer that I had in my solution anyway. So you can find other values of x that don't involve such large integers. But anyway, so as long as you can write x as any arbitrary element of this set as an integer of the form 5a plus 7b, you can do that by saying a equals like 10x and b equals negative 9x or something. Then you get that this 5a plus 7b equals x. Then you're done. You agree? Everyone agrees, right? Okay, so does anyone have any questions? Assignment 5, I talked about questions 1, 2, and 3. I think questions 1A and B are so easy. You should have already known those for the midterm. 1C, I think, was a little bit harder because that involved taking the ratio of two coefficients of binomial expansions, but seems that everyone that tried the assignment got those ones done pretty easy anyway. Don't leave this one to the last minute. You guys have a Math 137 midterm coming up soon, right? So when's that midterm? Monday or Friday? Monday. Okay, so don't leave this assignment to the last minute. Just half the class has already done it. At least finish the questions 1, 2, and 3, because the people that tried it seem to have got it done already. I've already given you huge hints over here. So so questions 1, 2, and 3, no one really has any questions. The people that tried it are already done. Other people didn't try it yet. So no more questions about assignment 5, I guess. Any questions about anything else? Persano.
How would you recommend going about identifying the special set?
I would not give you any more hints than I've already given because I've already basically solved 3 of the problems of the assignment for you. If you look at the lecture notes of some of the other instructors, they're not going through these. So they're basically repeating what's in the course notes, right? They're going definition, this, theorem, this, right? They're just writing down stuff that you can find in the course notes. So, you know, I'm treading on very thin ice here. I'm giving you huge hints for these assignments. Any other questions? What about the midterm? How's the midterm? Pardon me? Fair? Oh, very good, Prasanna. What else? Anyone else? Any other opinions? What was the hardest question on the midterm? 10 was the hardest question? You mean the one that I did for you in class?
No, but it's still difficult.
I said that if you have something of the form x to the negative k, then x doesn't equal 2, but it equals 1 over 2, right? And then if I said that if you have something like x to the k plus negative 1 to the k times x to the k, that's equal to 0 when k is odd, and it's equal to 2 times x to the k when k is even. All right. And then I said if you have something like that, then you just make k equal to 2m, right? K equal to 2m. And then that's pretty much exactly, I just put a 5 instead of a 2. So how many people found question 10 hard? That was also the hardest question for the other class. So I don't understand why, because I solved it for you, right?
They gave us hints though, that like was counterintuitive to like what you showed us.
Using
before.
that.
Really?
Yeah,
I said not to use induction.
yeah, no, they have like a hint like use x plus 1.
I thought it would be obvious that you would just take 1 plus x to the k plus 1 minus x to the k. They said to use that hint, right?
Yeah.
So you immediately turn this into a sum and this into a sum, and this is going to be something x to the k. This is something x to the negative x to the k. And then I told you that if you have something like this, you can factor them out. So you get this thing times x to the k plus negative 1 to the k x to the k, right? And then this is 0 when k is odd. This is equal to 2x to the k when k is even. And then you let k equal 2m, right? So I can't give you too many hints, right? I can't say that this is going to be on the exam and you're going to have to convert that to a sum and this to a sum. Hey, I can't give you everything, right? Okay. So no one has any other questions about the midterm? Who here wants to do something cool?
Yeah.
Only 4 people. All right. Okay. I have a function, x to the k. Hey, how many people took calculus already in high school? You guys know derivatives? Who here does not know derivatives?
It's been a while.
Everyone here knows derivatives? What's the first derivative of this?
Kx to the k minus 1.
Equals what? K x to the k minus 1? How many people don't know this?
Yeah.
Oh, yeah, sorry. I meant to say derivative of this, right? Okay, so you guys know this even better than me. All right, so I'm gonna write something else on the board, okay? d2 by dx2 to the k equals. All right. Justin.
Straight line k minus 1, so that you want to do I go up?
Yeah.
All right, so don't screw this up. What? There's no elevation. Okay, all right.
There's no what?
I thought there would be an elevation.
Oh, you thought there would be elevation.
Yeah, it's a really minor change in this term.
Right?
Yeah, write it a little bit bigger, come on,
Oh.
so that the people in the back can see. K times k minus 1, x to the k minus 2, all right. I will write this, you can sit down now. Thank you very much, that was a good demonstration. I'll write it in heavier. K minus 1 times x to the k minus 2. Okay. Let's get someone else. Arnav, you know derivatives, right?
Yeah.
I'm gonna ask you to do a different one, okay?
Okay.
You come up.
Do we pull a Wolfram Alpha for you?
Oh, wait, I just know she's not. The half.
What's even a half a derivative?
Oh, is that the?
Okay, sit down. Okay, so the half derivative of a function, did they teach you that? Okay, so I'm gonna teach it to you, because they're not gonna teach it to you in any of the courses, neither Calc 1, 2, 3, or 4.
Yeah, I haven't seen it before.
He hasn't seen it before either, and he took non-Euclidean geometry. So I'm going to teach you how to do the half derivative of a function, because we still have 5 minutes left. All right, first, what is the half derivative of a function? If I have a function, f of x, and I have an operator that acts on that function, which is the half derivative of the function, and if I apply that operator twice, what do you think I'm gonna get? What do you think I'm gonna get? So it's like the square root of the derivative operator in some sense. I apply that operator twice and I get the first derivative. Okay, so what's the half derivative of f of x? Well, in this case, I had x to the k. So now you know the definition of the half derivative of a function. And it's okay if I start using these boards too?
Yep, I'm not gonna follow you.
Okay, so the half derivative of a function. First of all, d by dx of x to the k is k times x to the k minus 1. d2 by dx2 of x to the k times k minus 1 times x to the minus 3. Okay, so let's try to do now the eighth derivative of the function x to the k, where a is an integer. Okay, I'm being easy on you. Oh, it's a positive integer. Let's say it's a natural number. That's easy on you now. You can follow a pattern, right? What am I going to get here? X to the power of what? I had k minus 1, then I had k minus 2,
K minus A.
k minus a. And then what am I going to get here? Henry. Okay, so k factorial minus k minus a factorial, right? Because I have k times k minus 1 times k minus 2 times k minus 3, but I'm not going all the way down to 1. I'm only stopping. I have k times k minus 1 times k minus 2, but I'm not going all the way down to 3 times 2 times 1. I'm stopping over here. So I have k factorial divided by k minus a factorial. So I have like k factorial, but then I'm losing all of these extra terms. You get it? K factorial divided by k minus a factorial. Got it? How many people are lost? Okay, so I didn't have much time to prepare for this, so I did make some notes. I know what I want to say next, but I forgot what the definition of the gamma function is. Okay, how many people have heard of the gamma function?
Yeah, it's in the calculus too.
It's in calculus too?
No, it's optional, it's optional.
Oh, it was optional in calculus too. All right. So the gamma function. Now, don't worry, you're gonna see some weird things going on here, but that's okay. It's just, I'm just defining some function. I can define a function in terms of a bunch of symbols and stuff, right? That's okay, right? So how many people have seen this before? Well, it was an integral part of your education. Okay, how many people have not seen this before? Okay, few people. I hadn't seen it in high school. I mean, those of you that did see it, how did you guys see it? Like in Ontario High School, they don't teach this, do they? All right, so the gamma function is a generalization of the factorial. Okay, so gamma of k plus 1 for integers k. The gamma function is equivalent, well, the gamma function of k plus 1 is actually the factorial function. Grayson's gonna ask the question.
No, I'm just trying to figure out.
He's trying to work out in his head that if you multiply this thing by this, if you do this integral, you're gonna actually get k minus 1 times k minus 2 times k minus 2. So if you do that integral, you're gonna see if k is an integer, you're gonna get k minus 1 times k minus 2 times k minus 3. So you actually get this, all right? But the beautiful thing about the gamma function is that it's not just for integers. So it's like a factorial, but what if I had pi factorial? What are you gonna write down there? Nothing, right? You're in the water. But you can do gamma of pi plus 1. And so if k is an integer, you get exactly the factorial. But if k is not an integer, then you can't do the factorial anymore, but you can do the generalization of the factorial, which is the gamma function. In fact, you can do the gamma function of e, you can do the gamma function of 1 plus I, where I is the square root of -1. So you can do the factorial of e in some sense. It's not actually called factorial anymore, but it's similar, or at least it's a generalization. All right, so let's we can erase some of this stuff now. So let's take what we had. Actually, I didn't even need to erase that. I have this right here, the definition of the 8th derivative. And if I ever start writing on something that is blocked by this, you let me know, Henry, okay? So this is dA over dx to the a times x to the k. This is the 8th derivative of x to the k. What am I going to put here? Gamma of k minus 1, good. And over here, gamma of k
Minus 3/2.
Whoa, where's the 3/2 coming from?
Oh, okay, well, I was thinking it was. Okay, no way. K minus 1 minus a.
K minus 1 minus a, okay, times x to the k minus a. So now you have the derivative, the 8th derivative of x to the k, where a doesn't have to be an integer. It could also be, you could have now, if you want, the pith derivative of the function. Or you could have the 1 plus square root of -1 derivative of the function. According to what I'm saying here, we can check whether or not it works later, but this is what I'm claiming right now. I've claimed it without proof. I'm not going to prove it for x equals 1 plus I. We haven't even started doing, you don't even know what a complex number is technically, according to the Math 135 curriculum. So let's just prove it for one case, because this is first year Math 135. Let's just prove it for the case where f of x equals x. So what do I have here now? What do I have here? Gamma, what do I have? For a equals half, what do I have?
1 minus a half.
1 minus a half? It's k minus 1, right? So
Yeah,
I have half minus 1. Oh, sorry, k equals 1. Yeah, you're right. Yeah. So this is 1 over here. So 1 minus a half. And then here, what do I have? 1 minus a half minus.
or no, it should be 1 minus 1 and then 1 minus 1 minus 1.
Yeah.
Oops, I did make a mistake. So I did make a mistake. I meant to say that, well, I think I wrote down first that k plus 1 equal, so k factorial is equal to gamma of k plus 1, right? So I made a mistake here. So that's k plus 1 minus a, right? I should have double checked that. So k minus a, k plus 1 minus a, yeah, so everything is right. So this should have been k plus 1, and this should have been k plus, yeah, so k plus 1 minus a. So I have k plus 1 minus a. Sorry, k,
2 minus a half.
One
right?
minus a half.
Yeah, it should be 1 plus 1 minus a half.
so I should have 1 minus a half plus 1, right?
And the numerator should be plus one.
Yeah.
Yeah, the numerator is just 1 plus 1. Yeah. Good, you guys are better than me at this. I get nervous sometimes. So x to the power k equals 1. So I have 1 plus 1, k plus 1. A equals half and k equals 1. So I have k minus a plus 1, right? Okay, good. And then the exponent, what's that going to be? K minus a. So that's going to be what? 1 minus a half. Okay, so this is going to be gamma of 2 divided by gamma of 2 minus a half. What's that equal to? 3 over 2. Good. Now this is x to the half. Now, someone type into their calculator gamma of 2. What is it? Or into their Wolfram alpha or whatever. Gamma of, just put the gamma, you can just type gamma function at x equals 2. Oh yeah, it is a integer, so it's just gonna be, you can just do that using the factorial, right? Okay. Yeah, so
Yeah, it should just be 1.
so it's just equal to gamma of 2 just equals 2, right?
Alright.
So
Yeah, one factorial, so it's one.
but what does it say when you type it into Wolfram alpha?
Now, if you use that formula that you wrote. then-
Yeah. But what happens when you type it into Wolfram alpha?
Undefined out.
No one's able to do that yet?
Gamma is 1, or what do you want me to type in?
Gamma of 2.
Gamma 2. okay.
Gamma of 2 is 1.
So gamma of 2 is 1. Okay, I might have had a plus 1 or something missing, but let's say it's 2 because I don't know. Okay, hold on.
No, I'm good with 1.
So, okay, I'm not, let's say, I think it is 1. Let's do gamma of 3 over 2. Can you do that in the calculator?
Root pi over 2?
Yeah.
Root pi over 2. Okay, that's looking good. Okay, so root pi over 2, right? So you all agree that this is just gamma of 2. I haven't made it 1 yet. So gamma of 2 is 1. That's what you're telling me?
Yep.
Okay, so I have, and then I have x to the half here. So this equals 2 over root pi x to the half. Is that okay? That's okay?
Yeah, I think it's okay.
We probably need to rationalize it though.
Hold on, we're gonna rationalize it in the next step. So the half derivative of x is 2 over root pi x to the half. All right, that's what I have here too. So let's now do the half derivative of the half derivative of x. So let's do the half derivative of that thing. So let's do the half derivative of the half derivative. And the half derivative is already 2 over root pi times x to the 1/2, right? Right? So let's do this. What's this gonna equal? What's the first thing we can do here? Say louder, I can't hear you. What's the first thing we can do? First thing, we have a constant here, we can pull that out, right?
Yeah.
Okay, so 2 over root pi times the half derivative of x to the half, right? And then what's the half derivative of x to the half? Yeah, I can't use anything below that, right? So let's go over here and let's do d half dx to the half dx to the half of x. This equals 2 over root pi times what? I have something of the form x to the a, and I want to do the half derivative of it. What's that going to be equal to?
Gamma of 1/2 plus 1.
Okay, so I have gamma of k plus 1, right? So I have now k is equal to half plus 1. Good. And here, what do I have?
One.
K plus 1 plus a half? Or is it minus a half? It's minus a half. Okay, and then this is k minus a? What's k minus a? What's k minus a? 1/2. K is a half and a is a half? Okay, so now we have 2 over root pi. What is gamma of 3 over 2? We already did that once, right?
Yeah. root pi
I'll say
over
root
two.
pi over 2, yeah.
Root pi over 2. And then what's gamma of 1?
One.
1.
Times gamma of 1, which is 1, times x to the what?
0, which is 1.
Yeah, okay. So then I have this thing and this thing, this thing and this thing. Gamma of 1 is 1 because 0 factorial is 1. So I have just x, right?
No, you have one.
You have one.
Oh, sorry, I have just 1, yeah. So the half derivative of the function, I haven't proven it for all functions, but this is just first year math 135. You haven't even learned derivatives yet. So I proved it that it was true for at least one function. For x to the k, the half derivative of the half derivative of the function is equal to the first derivative of the function. Because what's the first derivative of x?
One.
1. Okay, so now you know the half derivative of the function x. And you also know how to do the pith derivative of x to the k. And you know how to do the eth derivative, where e, you know how to do dE by dx to the e. You know how to do that now, right?
Yeah, you just said E equals 3.
You could do that, yeah. That will give you full marks. Now I just wanna show you something here. Okay, this is my function, f of x equals x. That's my function. What's the derivative of that function? The first derivative? 1? Okay. So this is the derivative. What's the antiderivative?
Area under the curve.
Okay, but for x, 1/2 x squared.
Yeah.
So it looks something like that. That's a quadratic. 1/2 x squared equals the antiderivative. So this is like d negative 1 to the dx negative 1. I don't know. I'm just writing that notation. All right, and then what's the half derivative? The half derivative, no, that's the half derivative of the half derivative. What's the half derivative of the function x? 2 over pi times x to the half. So that's like a square root, right? Look at that symmetry. You have the square root, that's your half derivative. D half x dx to the half, right? So you have the function, the derivative, the antiderivative, and the half derivative. Look at that symmetry. Justin.
Well, we're assuming the antiderivative has like a constant, constant of 0. It actually can be any arbitrary.
It could, yeah, you can shift it up and down if you want. That's just because we defined the antiderivative that way.
We're assuming that C is 0 in this case.
Yeah.
And that's, yeah, because
Yeah,
you can completely destroy the symmetry by adding.
you could, but you get what I mean,
Yeah, I get what you mean.
The fact is that there is the symmetry. It's just that it can be shifted because we defined antiderivatives in that way. If you defined antiderivatives to always have c equals 0, then we could define it that way if we want. What's wrong with that? It's just In fact, I don't know, I haven't tried to do d to the negative 1 over dx to the negative 1 of f of x. Maybe Grayson's gonna try.
It could be interesting, but I need to figure out where the root pi comes from first.
The root pi comes from the fact that the gamma function of 3 over 2, gamma of 3 over 2, which was somewhere here, wasn't it?
Yeah, gamma 3/2 is root pi over 2.
Yeah, gamma 3/2 is root pi over 2. And I gave you the definition of the gamma function, it's just this integral, right?
The reason I thought you because the gamma function is e in it, and we're ending up with a pi. And I need to figure out why that is.
What's wrong with that?
No, there's nothing wrong with.
Don't we have
Why though?
e to the I pi equals what?
Yeah, cos e up is or.
Yeah.
Yeah.
Yeah, so you have e's and pi's all over the place in math, right?
Yeah, no, I just need to understand.
Well, you got the definition of the integral, you know integrals. You can do the integral from 0 to infinity. But do you know how to do integral from 0 to infinity?
Yeah.
Okay, if you know how to do that, then you can do the integral where k equals 3/2, and then you should get 2 over root pi. Usually when you do integrals up to infinity, like, what's the integral, what's this? What's this?
So that would be 0.
Do you know that one? That has a pi in it. This has a pi, the integral of a Gaussian. You have a Gaussian, the area under that curve, that has a pi in it. So you can prove it. You're gonna need, you won't prove this one until math 237, because the proof of this involves double integrals.
Oh, okay.
But you can do it, right? Like you can do it numerically on your computer. You can do rectangles, right? You can do this. And you can see that it converts. You can do that on your computer. Yeah. Okay, so this proves that math is cool. Okay, anyone that wants to stay for the office hour, you're welcome to stay, and anyone else, go.